if you wanted to list 5 most transformational trends that will have the largest impact on the world's economy over the next 50 years, I would be strongly defending that space-based systems or new space, or however you want to call it, is one of those trends.
Hi, I'm Stephanie Tumampos, and you're listening to Down to Earth, the show where we talk to incredible geoscientists about their science and its impacts on our planet. As space technology becomes the frontier of innovation, many opportunities have arisen for those who invest in it. Today, we'll be talking about the NewSpace movement and how it's advancing research in the field of remote sensing. This episode of Down to Earth is sponsored by the Institute of Electrical and Electronics Engineers Geoscience and Remote Sensing Society's technical committees. The GRSS technical committees actively promote discussion and advances in many different areas of remote sensing, including modeling, earth science informatics, frequency allocation, spaceborne imaging spectroscopy, image analysis and data fusion, instrumentation and future technologies, and environmental analysis and climate technologies. To learn more about these technical committees and how you can get involved, visit their website at grss-ieee.org/technical committees.
What we've seen is proliferation of investment into space. And that means that there is more research, there is more satellites being launched, there is more data being collected, there is more applications being explored, there is more external companies that are getting involved into how to potentially convert what the space, along with the new space, is really bringing to them. And all of this is resulting in a lot of good things.
This is Rafal Modrzewski. He's the CEO and co-founder of a microsatellite manufacturing company called ICEYE. He started this company with his co-founder Pekka Lorla in 2012. Together, they were inspired by the challenge of figuring out how to create smaller satellites so more people could benefit from them.
The early experiments with how much efficiency and just good we can bring by correctly using the sensor capabilities that are completely new. And we don't even know yet everything. We know very little. That in itself allows you to keep on imagining completely new use cases, and they are more and more exciting. So that really open-ended journey, which as you progress through it, you can see how impactful it is. That's really what personally drives me.
Rafal's passion for the future of satellite technology has continued to today and is part of what has made ICEYE so successful. Fun fact about ICEYE, they are the first organization in the world to launch a synthetic aperture radar satellite with a launch mass under 100 kilograms. It's innovations like these that have put ICEYE and companies like it at the leading edge of the new space movement. Tell us more about ICEYE. How did ICEYE come to exist?
The story is probably somewhat of a traditional startup story in a way, I guess. But when I was studying radio science engineering and Pekka was studying GIS information sciences, actually, the NewSpace, or sometimes differently referred to as a CubeSat revolution, that was going on. And that meant that universities around the world were starting their own space projects and launching their own satellites built in a new way with this new form factor. And Aalto University was one of those universities. The professor here at Aalto asked whether anyone wishes to join the project. Both myself and Pekka, we've joined, and that's how we got entangled into this whole new concept of space. As we were building that, it wasn't just us. It really was the entire community that was trying to figure out how could we harness the power of this new concept of space for the betterment of people, right? And for us, ice monitoring was really the first use case that we wanted to solve, which is why the name. And for that, we needed data from an instrument called synthetic aperture radar, which ultimately led to what ICEYE is today, a world leader in SAR imaging. But it all started from ICE and the university.
Mm-hmm. Out of all the startup companies, there are so many around the world. What makes ICEYE different from all these companies?
I think there are certain things that make us unique. Probably the most important part is the SAR technology that we have developed. When we started, SAR technology was somewhat perceived as almost impossible to miniaturize. So people have already been building small optical satellites, people have been building small signal intelligence satellites, but no one has really been building a small SAR satellite. That's usually linked to the fact that you need a high power to aperture ratio, so either a very large antenna or a very large amount of power. And both of those are really difficult to put into a small satellite. Now, we thought that that was an exceptionally interesting challenge, which is why we decided to try. And that really resulted in us trying to redesign the whole system once again from a clean sheet of paper. And as a result, ICEYE is a company that is very highly vertically integrated. Almost the entire design of our satellite, both the design as well as manufacturing, is being fully done in-house, which means that we build our satellites very, very fast and we can iterate on the design very quickly. And that ultimately has led to ICEYE taking over the leadership of the SAR spaces within the NewSpace, leading to the largest constellation there is. We've so far launched 14 satellites, leading to some of the kind of most innovative product lines like the daily coherent ground track repeat, which we have recently launched, or ScanSAR from a microsatellite that we have recently launched. So I think if you want to think of ICEYE's uniqueness, I would say we are probably the only company that is focused on synthetic aperture radar that has designed the entire instrument in-house.
That's pretty interesting. Now, we're here to talk about NewSpace in general. So, can you give us a definition of what is NewSpace?
NewSpace is a term that doesn't really have a very good definition. And I think generally you could broadly refer to NewSpace as the combination of all companies that have emerged following the CubeSat revolution. Right? So all the different startup and nowadays already somewhat mature companies that have developed as a consequence of students around the world investigating how to build satellites in a cheaper, faster, more iterative manner. All those companies are what's really considered the new space wave. And that's not only the companies that have been involved in building the satellites themselves, but also the ones that have looked at providing infrastructure in order for the satellites to be built, the downstream infrastructure, so the conversion of data into information content, any sort of supporting software of that infrastructure. But they all tend to be linked to a certain period of time and maybe a concept of how to build satellites, which is what followed really the so-called CubeSat revolution.
For our listeners, can you explain to us what is the CubeSat revolution?
Yes, it's another one of those terms that's, I guess, used more often than it perhaps should be, and I'm partially guilty of that. It's quite generic term. CubeSat, to be very exact, specifies a satellite that is built from the mechanical perspective out of cubes that are 10 by 10 by 10 centimeters in size and have a specified set of external mechanical interfaces. And a CubeSat can contain one of those cubes, and then that's a 1U CubeSat, or it can contain 3 or 6 or 12. I believe 12 is what has been built as the largest. And that means that it has 12 units, 1 cubic decimeter each. Now, why was that a big revolution? Is because people haven't been building satellites of that size in the past. Not only they haven't been building satellites of that size in the past, but along with the mechanical interface, which became standardized, came a standardized launch service, which meant that if you were to build a CubeSat, you could reasonably easily purchase what's currently referred to as access to space, but what really is a slot on a rocket. And now, both of those really led to decrease in cost. That meant that if your satellite is small, 1 cubic decimeter, it probably is light, which means that the launch service, which is standardized, won't be that expensive. And as an institution like a university, you actually can afford now to invest into the entire mission and end-to-end capability, where you start seeing that people can begin by designing the mission requirements. And once we've started building spacecrafts in a way where they are already much smaller and cheaper, the numbers have skyrocketed, no pun intended.
So I'm getting the sense that this new space movement is, in many ways, almost democratizing space by making it more accessible through lowering costs. But I think there's still a lot of fear of private companies getting into the space industry. I think that when the general public thinks of new space, they're thinking of people like Elon Musk. So, what would you say to folks who are unsure about the new space movement?
Yes, it's an interesting question. Let me give this a second.
Coming up, we find out Rafal's thoughts on this question of privatization of space. Rafal also tells us why companies innovating in the space sector is so essential to our future as a planet. And never mind Venus as Earth's twin. This whole new space movement is leading to a digital Earth twin, and Rafal tells us how. All this right after the break.
Are you looking to make an impact in geoscience and remote sensing science? Then consider joining one of the Geoscience and Remote Sensing Society's technical committees. From environmental analysis to spaceborne imaging spectroscopy, each technical committee advances innovative research and technology in a specific field of remote sensing. By joining, you'll connect with a community of passionate researchers and professionals who are fostering important international collaborations and steering global research agendas. You'll also gain access to the latest news and state-of-the-art research in the field. Expand your network, enhance your career, and make a difference. Join a GRSS technical committee today by visiting grss-ieee.org/technical committees.
Welcome back. Today we've been speaking with Rafal Modrzewski, CEO and co-founder of the microsatellite manufacturing company ICEYE. So far, we've covered the basics of NewSpace, a term that represents a movement of private aerospace companies working to develop low-cost access to satellite and space technologies, and space in general. ICEYE is among these innovative companies and was responsible for launching the first synthetic aperture radar satellite with a launch mass under 100 kilograms. As Rafal explained, microsatellites and CubeSats have allowed institutions like universities to access space where before only government agencies could. However, as we asked Rafal right before the break, many in the general public are queasy about the idea of companies breaking to space. So we asked, what did Rafal think about this? Here's what he had to say.
What I think is happening with new space is the large space exists there, and the public sees most of the large space because it's large. So it's very, very, very visible. The rockets are big, and the flames are large, and the amounts of money are obviously very, very big too. And the personalities that run those companies are very frequently billionaires, and they are famous and they are very visible. Now, what happens in addition to that is actually that there's a significantly larger amount of smaller companies, those new space companies very often, that are really trying to work on how to convert different capabilities that can be reached through space technology into products that we can use in our business or everyday life. And those products will actually be provided to us at a cost level that's very accessible. Not many people anymore think about the fact that Google Maps is really enabled by space-based system, which is GPS system or a GLONASS or Galileo system, whichever one you're using. Those satellites are state-of-the-art technology orbiting consistently in MEO orbits, providing a free of charge service, location service, which is essential for scooters to Uber to Google Maps to any other application of our life which uses the location-based services. So, if I can probably define one single trend which is currently driving many of the companies, is useful, low cost, accessible end applications which are fed by the data generated through all those small spacecrafts that have been launched.
I think it's really relevant that you brought up Google's GPS service. I think it's a clear example of how corporations can benefit society. So you keep mentioning the importance of making the data usable by the end user. How do you do this at ICEYE?
I don't think we have a silver bullet for that, but look, we work with the user to define their requirements very correctly and accurately. We need to first of all, understand where their pain points are so that we can really design an information product that solves those problems. And then there's a technical research and development really that starts, which may be short or maybe a longer phase, depending on how complex is the problem. But really what we need to do is we have to learn how to convert the data into the type of information service that addresses the pain point of the user. So you have to build this last mile delivery or this downstream part of the product line. Otherwise, the users won't really feel empowered to convert the data into information that they need. And so that meant, from ICEYE's perspective, that we had to develop capabilities in the domains that we did not anticipate when we were starting the company. That was software engineering, analytics engineering, and honestly, trying to solve problems within specific industry meant that we had to develop knowledge and expertise within those industries, whether that's forestry or insurance for that matter. And that created that made an ICEYE even more interesting company, but also even more diverse in terms of the different types of knowledge and capabilities that we have to have in-house.
Mm-hmm. I want to ask you, in your opinion, why is it important for companies like ICEYE to get involved in the space industry, which was mainly dominated by research before?
I personally think as all of it as space. I just think about it as different areas of space industry that have made different trade-offs, and ultimately that has resulted in somewhat of a different technical products. It's something like asking yourself whether all computers are the same. So think of let's say the old space as those big supercomputers that used to be only accessible to governments and universities, right? Now, what has happened is at a certain point, a personal computer emerged. And those personal computers weren't as powerful as the big ones, but they gave the public access to the technology that used to be accessible to a selected few. And now the NewSpace brings a very similar set of capabilities, right? We used to have, and we still have, the large satellites, and those satellites provide exquisite capabilities that are accessible to the selected few. Now, the smaller satellites, which are being launched in a larger amount, they may not even be as good, but they are at lower cost and they are much, much more available. Very often the term that we are using internally within our community is the democratization of data. It's really about making the space-based data and space-based services available to as many people as possible. So at the end of the day, I think the revolution itself that took place and the emergence of all those new companies is really actually a very positive thing.
I love the analogy of access to supercomputers back in the old days and how it led to smaller computers that can be used by everyone. It's actually a great way of differentiating between what governments are able to do in the space industry versus what corporations can do. And you mentioned the democratization of data. Did you have any additional thoughts on that? Is this part of the future you envision for our society?
I really think what we are looking at is a GIS data revolution more than a new space revolution. And I think space has a bit of a sexy vibe to it, which is like people like to call it a new space revolution. But I think that what the future holds for us is really something that I personally like calling Earth's digital twin, an almost near real-time Earth, and our ability to know everything that's going on in every single place around the globe. Obviously there's question about the resolution and so on, but as the time progresses, I think we will be able to observe the entire globe. We will be able to observe this globe across the electromagnetic spectrum. We'll be probably able to observe not only the surface of the globe, but also the atmosphere, as well as what's hidden beneath the soil. And all of that information will be collected regularly and reliably. And that information will create really a foundation for all sorts of applications that will be built on top of that. I don't really even know how many transformative applications there are going to be, but just given the amount of knowledge that we will have, I'm certain that our lives are going to look completely different than how they look right now.
Well, that's all for this episode of Down to Earth. To learn more about ICEYE, connect with them on LinkedIn at ICEYE and on Twitter and Facebook at ICEYF as in Frank I. Be sure to check out other Down to Earth episodes on Spotify and Apple Podcasts, and give our sponsors a follow at IEEE_GRSS on Twitter and Instagram, and IEEE Geoscience and Remote Sensing on Facebook and LinkedIn. This episode was produced by Nicole Bedford from Nicole Bedford Films, with help from me, Stephanie Tumapos. Graphics and design by Mylene Briggs of Killam Media. And a special thanks to Fabio Pacifici and Keely Roth for their support. I'm Stephanie Tumapos, and you've been listening to Down to Earth.